Um, if you've ever worked at a pizza place, or you ever will, you'll fold pizza boxes, and they come in flat packs, and you just
Oh,
fold them up, and they look like nice little prisms. So
oh, that's cool.
yeah, it's kind of a neat thing here. Why would any of this stuff matter? Like, why would you care what, a cylinder ends up
Uh,
into?
just in case you do end up folding those pizza boxes or making those cans.
Okay. So what typically goes on the outside of the pizza box or the can?
What do you mean, like the brand name?
Yeah, branding. And I mean, if you've ever bought something, have you noticed how most cans have the same sort of shape, no matter how large they are?
Yeah,
You've ever wondered why that is?
no, but
Okay,
now I am now.
slightly curious. Um, there's a couple of reasons. One is there's a preference for height and width that it's called the golden ratio. You ever heard of anything like that?
I've heard golden ratio before.
So if you look at a modern TV, right,
Hmm.
it has a certain like visual appeal because it's got this ratio to it that looks better. If it gets too thin, we don't like that. And if it gets too tall, we don't like that either. And if it's too square, we don't like that either. Do you agree with that, or
Yeah.
you're
Is so is this just based on like people's preferences, the
the,
public's?
well, it's interesting because like if you were to, they've done studies where if they like showed you all these different ones, people always tend to the one that's the golden ratio. And it's a really interesting thing. Um, so that's not the only reason though. You mentioned it before, branding, because you can actually have the same volume with many different size, cans, right?
Hmm.
But you need to put a label on it. You want people to know that this is progressive soup, or pumpkin pie mix, or whatever it is, right?
Yeah.
You want, and that needs to have, because you could also have a can that's, like this. And there are certain ones that just appeal because you can actually maximize the surface area of the can. And that's the label. That's the thing that people care about, um, when they're branding these things. Applies to
Yeah.
things like, shampoos. Just next time you're at the store, oh, cereal boxes. Why do you think they're like that?
There. So
There's
you
a
can make an image.
that and the people like that look. Like, people want a cereal box that looks tall and narrow on the sides. And it's all related to what you're doing right now in this class. Okay. Because if you've ever been to the store and you've seen what they've got, the regular size, and I guess they call them family sizes now. I don't even know what
Yeah.
but they're bigger, but they're actually the same ratios.
What?
They're the same ratios. Like, the if you were to measure the height and the width, it would be in the same ratio as the height and the width of the family size,
Oh,
the bigger
that's cool.
box. Yeah. Same thing with the soup cans. And our eyes are sort of drawn to these images, and it's there's math that goes into that, which we can't do today. It's a little bit beyond where you're at, right now, but I think conceptually you understand the idea.
Yes.
And yeah, that's very important here. So looks like you're moving towards surface area. So
Oh, we've
let's
done surface
you've done
area.
surface area. Okay. Have you done volumes of these solids?
Yes.
Okay. That's interesting. So where do you think you guys are going then in this class?
So the way our school does things is they like teach the same thing every year. So they teach some of the same things like every year.
Mhm.
And we've had this lesson since like the fourth grade. So
Yeah.
I have
Hit,
no idea where they're going with this one.
yeah, hit them over and over again. The surface area, I think, is the hardest one to find. So we're gonna do some surface area problems. That'll be the best way for us to utilize our time today for this. And so let's start with something very nice, which is a box. Now, what I like to do, this might be something different than what you've seen in class, is the box that is drawn here, to me, it has a front and a back, which are the same.
Mhm.
It has a side, a left side and a right side that are the same. And it's got a top and a bottom that are the same. Do you agree with that?
Yes.
And I like to label those. I like to label 6 and 3, 6 and 3, 6 and 6. And then when I find the area of each, I know how many of those I need. Like since there's 2, since the area of this is 18, I'm going to double it. 36, 18, there's 2, I'm going to double it. This one is 36, I'm going to double it and add these all up. And that's 144 meters squared.
So that's all together.
That's all together because we want the surface area. The surface
Oh,
is,
the lateral surface area would be one of them.
well,
right.
you got to be careful. There's a difference between surface area and lateral area.
And that would be the size of one.
Do you know the difference or do you want me?
Lateral area is the size of one side.
No. The lateral area is, well, okay. How do I want to say this? Because I don't think you're wrong in what you're saying. So to me, so this may be a thing that is different based on how you hear it in class. The lateral area does not include, it excludes the base, the thing that it sits on.
Weird.
Yeah. And I don't like that, but that's the definition. The area of one face is what we were just discussing, but the surface area is all of them. So I always like to start with the surface area. Do you think that's the question?
No.
Okay. So where this gets more difficult, we're going to look at a triangular prism, is you have to be able to differentiate between the various pieces. So I like to draw them like I see a triangle. Okay. And it's actually a 3 and a 4, and there's 2 of them. So I might indicate that there's 2 of them. Then there's this sort of back piece, I don't know, back left piece, 7 and 3. And then there's this one on the front. There's only one of those. That's 4 and 7. And then there's the base, which is 7 and 5.
Okay.
And you can always count. You can say, okay, there's 1, 2, 3, 4, 5. Okay, I got 2, 3, 4, 5. Okay. But that is how I like to break these up. Even in, having done these thousands of times, I still like to break them apart.
Okay.
Okay. So we find the area of each one individually and then add them up.
So
This one's 12, we'll say times 2.
and what does the 12 represent?
The area of the triangle. I'm sorry. 6 is the area of the triangle.
Because you divide by 2.
Yeah.
Okay.
Good
And-
catch.
Okay. So add them. What do we got? Okay, so that's gonna be 27. And then
Yeah, go ahead and add these up for us, please. Like I would add 12 and 28. That's 40,
oh yeah, okay.
75 plus the
90?
20, 96.
Oh,
Okay, now if I asked for the lateral area, what do I need to tell you
Mm.
if I'm asking for the lateral?
wouldn't we use 6 because their area is 6, not 12.
There's 2 of them though.
Oh, oops, never mind.
Yes, yes. So I made the mistake with the wrong area. You got to double count. Yeah. So
Okay, okay.
yeah, and please ask if you ever think I make a mistake. I do. it's going to happen. So just check me along the way. So here's my question for you. If I asked you to find the lateral area, what do I need to tell you that I've not told you right now?
How to find it?
So what I have not told you is the base. I haven't told you what this is sitting on.
Oh,
And depending on how you look at it, I mean, it could be sitting on any of the sides. Okay. So to do that, I have to obviously tell that to you. Okay, so here is, let's look at a pyramid. Pyramids are always interesting. We're still trying to figure out what the pyramids were used for in Egypt. Okay. All right. So this is called a square pyramid, and it's square because the base is square. So you have one square base. How many triangles do you have?
you have 1, 2, 3, 4, 5, 6.
4 triangles.
Oh, yep. Sorry.
4 triangles. This is you got to, and if you haven't seen this before, just, it'd be good to have a visual of this, but we don't have it. What is the height of the triangle and what is the base?
The height is 8.7 feet.
Okay, and the base is 7. Okay, and there's 4 of them. Okay, so keep that in mind when you're multiplying, because you're doing 1/2 base times height, but then you're multiplying by 4.
Okay.
So what that means is you can simplify the calculation by doing the 4 times 1/2 first.
Is so that would be 4/4 times 1/2.
No, 4/1. 4/1
Oh,
times
okay.
1.
4/1.
So it becomes 2. Half of
Okay.
4 is 2. And the reason you might do that is because that might make the next calculations easier, maybe. All right. So go ahead and multiply that out, add up the other one, and let me know what you come up with.
Okay, so that's good. Okay. Good. That's 60.9. Oh, I need to erase that. 121.
Point?
Oh, 0.8.
Yes. Okay. So then you also need to add the area of the square base.
Okay. Oh, wait. 170.8.
Yes. So the total surface area is 170.8. Now, if I asked you for the lateral area, it is safe to assume the pyramid is sitting on its base.
Yes.
Okay, that's very reasonable. Now, if you had a little pyramid figure, you could flop it over and it could rest on one of its other faces, but that's a pretty safe one. So the lateral area in this case would be 121.8 because it excludes the base. And if you think back to like a soup can, you ever looked at the bottom of a soup can?
Yeah.
Not much there. Usually a date. Not really much, because most people don't look at it. Same with a pizza box. Once it's resting on the table, you don't. So it's really it's really the lateral area you care about in marketing, because that's what people are going to see.
Okay. Okay.
And that's just kind of an aside here. So some problems for you to work out here. And I strongly recommend, like I did, drawing the faces and labeling them, but let me give you a new problem to work on here on your own.
Okay.
Get my mouse to work. Here it is. All right, so I want just the surface area, please. Just the surface area of this.
Okay. $18 times 6 is 108. Okay, so 108 times 2. No, times 4. No, times 2. Okay. Oh, 216. I could have mental math that. 6 20 times 18.
So you have to pair up all the numbers. You're going to do 18 times 6, 18 times 20, and then 20 times 6. And that would be depicted if you made the three figures, three rectangles.
Okay. Hold on. Okay, no, 20. Okay. Messed up. Up 588 squared.
You're off by, so give me your values here. What is 18 times 6?
18 times 6 is, what do you call it? 18 times 6, 108.
Okay, but you got to double that, so that's 216. Okay, 18
Oh, I
times,
didn't double these. Oops.
yes, okay. That's because you're off by exactly a half.
Okay. So 216 plus 720 plus 240.
Yes, you got to add them all up.
Okay. Okay, so that's gonna, okay, that's 6. 3, okay, 7, and then 2, okay. 1,176
Meters squared.
meters
Yes,
squared.
very good. Okay, let's look at another problem here. This might be our last problem of the night. Sometimes the lines can be deceptive. I recommend looking at this as a top and bottom, which is a triangle. And then you've got the front, and then the left and the right. They're rectangles as well. So that's my
Oh,
hint
okay.
for this one. Go ahead and try working it out. Let me know what you come up with.
Oh. Wait. So 5 times 3.7. Oh, I messed up. 5 times 3.7 equals 18.5. And then 18.5 times 2, because there are 2 of them. 68.45 or 68 and 45 hundredths.
You're doing the 3.7.
Yeah, 3.7 times 5.
Okay, very good. So you got 2 of them, right? So
Yeah.
you got to be careful there because it's 1/2 base times height, but you're multiplying by 2, so that cancels it. So it's really just 5 times 3.7,
Oh, okay. So,
which ends up being 18.5.
okay.
The front one, just because we're running out of time here, is 4 and 5, and then the side ones are 5 and 5. Believe it or not.
Okay. Oh, okay.
Sometimes it's just hard to distinguish there what you've got. But it looks like it's 20 plus 25 plus 18.5.
Okay.
I'm sorry, there's 2 of these. So I'm sorry, that's gonna
Oh.
be 50.
Yeah, 50. Got it. Okay, add this all up. And it's still 18.5, or is it
It's
times
just,
two?
it's just 18.5. We already accounted for the
Okay, okay.
times two.
63.5 meters or inches squared.
This is the doubled is the 50. So it was 18.5
Oh.
plus 20
Yeah, I messed up.
plus 50, which is 88.5.
Okay.
So just a lot to keep track of, but you think you did pretty well there. So I'm gonna go ahead and stop right here for